According to the M number, a variation of Poiseuille's law, which of the following changes would result in the greatest increase in resistance to flow through an ECMO cannula? A. Doubling the length of the cannula. B. Increasing the blood viscosity by 20%. C. Reducing the cannula internal diameter by 50%. D. Increasing the pump RPMs. Answer: C. Reducing the cannula internal diameter by 50%. Explanation: resistance is inversely proportional to the fourth power of the radius, $r/4. While length and viscosity matter, a decrease in diameter has a massive, exponential effect on the pressure required to maintain flow. When selecting a drainage cannula for a patient, what is the primary goal regarding pressure flow curves? A. To achieve the highest possible RPM. B. To ensure the desired flow is achieved with a negative pressure, suction, of less than -60 to -100 mm of mercury. C. To ensure the cannula is at least 30 French in size regardless of patient weight. D. To minimize the amount of heparin needed. Answer: B. To ensure the desired flow is achieved with a negative pressure, suction, of less than -60 to -100 mm of mercury. Explanation: excessive negative pressure, suction, leads to hemolysis and chattering. A well-sized cannula allows for high flow rates without reaching dangerous negative pressure limits. In an oxygenator, why is the membrane surface area, typically 0.8 to 1.8 square meters, a critical factor? A. It determines the amount of prime volume needed. B. It dictates the maximum amount of oxygen that can be transferred to the blood, O2 transfer capacity. C. It determines the color of the blood. D. It prevents the pump from overheating. Answer: B. It dictates the maximum amount of oxygen that can be transferred to the blood, O2 transfer capacity. Explanation: the larger the surface area of the PMP fibers, the more contact the blood has with the gas, which increases the ceiling for oxygenation and CO2 removal. What is plasma leakage, and why is it less common in modern PMP, polymethylpentene, oxygenators compared to older polypropylene ones? A. PMP is a solid, non-porous material that allows gas diffusion but prevents liquid passage. B. PMP is coated in gold. C. PMP has larger pores that let plasma flow through safely. D. PMP is only used for short-term support. Answer: A. PMP is a solid, non-porous material that allows gas diffusion but prevents liquid passage. Explanation: older membranes were microporous, meaning they had tiny holes that would eventually clog with proteins and leak plasma. PMP is a diffusion membrane, solid, which acts as a true barrier to liquid. How is the oxygen extraction ratio, $O_2 calculated using saturations? A. SA2/SbO2. B. SA2/SbO2/SA2. C. POW2 times 0.003 plus HB. D. Flow/BSA. Answer: B. SA2/SbO2/SA2. Explanation: this calculation tells you what percentage of the oxygen you are delivering is actually being used by the tissues. If SA2 is 100% and SbO2 is 60%, the O2ER is 40%, indicating a high demand or low supply. If a patient on VV-ECMO has a stable pump flow but their systemic SA2 drops from 95% to 80% when they start shivering, what is the most likely cause? A. Oxygenator failure. B. Increased metabolic VO2, oxygen consumption, exceeding the ECMO support. C. Recirculation has suddenly stopped. D. The sweep gas has been turned off. Answer: B. Increased metabolic VO2, oxygen consumption, exceeding the ECMO support. Explanation: shivering significantly increases VO2. If the ECMO flow is fixed, it can no longer provide enough oxygen to meet this new, higher metabolic demand, leading to a drop in systemic saturations. Which of the following is the most reliable indicator of internal recirculation in a dual-lumen, Avalon, cannula? A. A drop in the patient's heart rate. B. A high premembrane saturation, SpO2, despite low patient systemic saturation, SAW2. C. A high mean arterial pressure, MAP. D. Bubbles in the venous line. Answer: B. A high premembrane saturation, SPRE-O2, despite low patient systemic saturation, SAW2. Explanation: if the drainage port is sucking up the freshly oxygenated blood from the return port, the blood entering the ECMO machine, premembrane, will look artificially bright or highly saturated. What is the delta P, across the oxygenator primarily a measure of? A. The patient's blood pressure. B. The resistance to blood flow within the oxygenator. C. The speed of the sweep gas. D. The temperature of the blood. Answer: B. The resistance to blood flow within the oxygenator. Explanation: delta P is the difference between the pressure entering and leaving the oxygenator. An increase always suggests an internal obstruction, usually a clot, or a sharp increase in flow rate. In VA ECMO, LV distension can be identified on an echo by A. A small, hyperdynamic left ventricle. B. A dilated left ventricle with a closed or barely opening aortic valve. C. High flow through the mitral valve. D. Rapid heart rate. Answer: B. A dilated left ventricle with a closed or barely opening aortic valve. Explanation: because VA ECMO increases afterload, a weak heart may not be able to push the blood out against the ECMO flow. The LV fills up with blood, distends, and the aortic valve stays shut, which can lead to pulmonary edema.